Limits at infinity. Basically, we're wondering what happens as you go far to the right and far to the left on a graph. Going far to the right meaning as x gets bigger and bigger, meaning positive infinity, and as you go to the far to the left, meaning negative infinity. We want to know, does your graph level out at a horizontal line? If it does, it has a horizontal asymptote. If it doesn't, does it go up? Does it go down? Or what? And so that's what we're going to try to accomplish by looking at infinite limits. Now, the easiest way to do this one here is you look at the most influential on the top, the most influential on the bottom. Because when you're plugging in really big numbers, because we're looking at our limit going to infinity, really the only thing that influences is the most powerful on the top, most powerful on the bottom. So we end up with this. Well, your x cubes then drop, and you just get 3 over 2. So in this case, if you were graphing it, you would have a horizontal asymptote of y is equal to 3 over 2. But for the sake of what we're looking at, we're just looking at our limit as x approaches infinity of f of x. And so you could say it's equal to 3 over 2. This one over here, since we're dealing with a root minus a root, we're going to do what we've done before when we have a root minus a root, and we're going to eliminate those roots up there by looking at our conjugate. So we're going to multiply the top by the conjugate, and if you multiply the top by the conjugate, you got to multiply the bottom by the conjugate. You FOIL out the top, and then just leave the bottom alone because it's being multiplied by 1. So the top simplifies down to just a over your root of x plus a plus x, root x. Well, when you're looking at this here, it's really just some number on top. The bottom, as you put in a bigger and bigger number here, becomes big, plus another big. Well, it ends up being some number then over something really big because it's a big plus a big. And any number over something really big is always going to be close to 0. For this one here, since we have our exponent being of 2 on the bottom, we want to deal with that squaring. So we're not going to do anything to the top. Then all we're going to do is just FOIL out the bottom. Remember, when you're foiling, because it's squaring, you got to take a 1 plus e to the x times a 1 plus e to the x. Also remember, when you're doing your e to the x times your e to the x, you have to add your exponents. That's why we have our 2x right here. Now, just like the first problem we did, I'm going to look at the most influential on the top over the most influential on the bottom. Well, then your e to the 2x's drop. So you're left with just 4. Over here, let's go ahead and deal with that negative exponent, which means just 1 over that, still times your sine. Well, you know sine is always between 1 and negative 1. Now here, if you put a big number in for x, in the exponent, you get a big number there. So you get a big number raised to a big number, which is going to be really a 1 over a big number. And 1 over a really big number is 0. Timesing it by something between 1 and negative 1. Well, 0 times anything between 1 and negative 1 will be 0. Now, on this one here, for the most part, you could go ahead and look at the most influential over your most influential. You end up getting a 3x over, and it would be a root 2 times just an x to the first, because The square root of your x squared is x. It's technically, though, absolute value because what sign's in front here? It's a plus. Now, if you end up going ahead and putting in a really big number, because we're going to positive infinity here, it'd be 3 over that huge number times root 2 over that huge number, because your absolute value won't do anything. So those huge numbers would drop out, leaving you with a 3 over a root 2. Then if you rationalize that, you get a 3 root 2 over 2. You could also use that same approach over here on the far right problem. However, on the far right problem, keep in mind we're going towards negative infinity. If we're going towards negative infinity, when we put in that on top, it's going to be a negative 3 times a big number over a root 2 on the bottom times that big number, and they would drop out. And so you get a negative 3 root 2 over 2. Now, technically speaking, if you're in a math class in college, they would want you to go ahead and divide everything by, on the top and the bottom, by 1 over the square root of 2, or square root of x squared. So when you do that, you will get this. Well, if you go ahead and follow this all the way through, as x gets really, really big, you're still going to go ahead and get the same answers. And then when you put in a negative big number, you're still going to get the same answer that we did before. It can be done either way. Here, you're going to go ahead and put in a big number and cube it. A big number cubed, that's positive, is a big positive number, which means it's going to go up farther and farther as you go to the right. So it's going to increase without bound, meaning it has a limit of positive infinity is what it diverges to. Here you're going to put in a negative number. Well, a big negative number cubed is a big negative number, which means as you go far to the left on your graph, that's what it means by as x approaches negative infinity, it's going to diverge towards negative infinity. Now, you should remember that these will not have horizontal asymptotes because the degree of the top is greater than the degree of the bottom. Whenever the top has a higher power than the bottom, then it's an oblique asymptote. Hopefully you remember to find your oblique asymptote, all you have to do is do longhand division or synthetic division. And then it's just your quotient. Well, if you go ahead and do that, and you work that out, you would get this. Your 6 right here is your remainder. This is your quotient. Now, if you were looking for your oblique asymptote would just be y equals your quotient, and we'd have that. Now, for the most part, as you put in a bigger and bigger positive number here, it's going to be 2 times that big positive, minus 6 doesn't change it. This is going to be essentially 0, so it's a big positive number. Some people may also want to look at your original by taking the most influential over the most influential, and you'll get a 2x. And now when you put in a big number that's positive, you will get positive infinity. If you want, you can look at that also in the same way in the one on the right. Put in a big negative number here, and you will get your negative infinity. Whether you put it into that, most influential over most influential, or what you get after you do your dividing, doesn't make a difference. You get the same answer either way.